Alright guys, looks like we are live, so we will get started. Alright, so this lesson is voltage and current dividers. It's the second to last lesson in the test material. It's talking mostly about the law of proportionality and how it can be used to solve circuits where you don't have all of the information that would be required to solve the circuit. We'll get into it a little bit more as we go, but current divide. So number one is current divides in a parallel circuit. This is with your only two options, series and parallel. Current stays the same in a series circuit, so it can't divide. All the separate legs have a portion of the current in a parallel circuit, and it all adds up to the total. Voltage divides in a series circuit. And that's basically the same thing. Every resistor drops a portion of the voltage, and it all adds up to your total. In any parallel circuit within a combination circuit, the greater current will flow through which resistor? So, in this one, think about lanes at the grocery store. The lane with the lowest resistance is going to get the most people through it. So you'll have more current through the smallest resistor. Adding more applied voltage to a circuit will increase the voltage drop across individual resistors in any circuit. So yeah, if you go over there and take the knob for voltage and crank it up, the voltage is going to go up across the whole circuit. I mean, that's a fairly straightforward question. Yeah. More applied voltage, more voltage drop. Because all of the voltage has to be dropped. If a resistor in a parallel circuit has twice the resistance of a second resistor in another branch, it will have, so it's parallel, it has twice the resistance as another branch. So it's going to have half the current. Because it's, I mean, there's several ways to say this, but it having twice the resistance means half as much current can get through it. They both have the same amount of voltage. One thing you can do in a question like this that isn't worded just 100% straightforward, you can take and just make two resistors, 5 ohms and 10 ohms. Say it's 20 volts and 20 volts. Because it's parallel, they're going to have the same voltage. 20 divided by 5 is 4 amps. 20 divided by 10 is 2 amps. It has half the current. Just set up circuits for yourself whenever you get to questions that are abstract. And you go, okay, well, I can just throw the numbers in and make the math come out for yourself. Don't try to memorize all these different scenarios. Just build your circuit and work it. Series circuit supplied by 48 volt power supply consists of the following loads. So it's a series circuit, 200 ohm, 500 ohm, and 600 ohm. Use the law of proportionality to find the voltage across R2. So, I'm going to draw this out. Two, 5, and 6. Alright. We have 200 ohms, 500 ohms, and 600 ohms. The law of proportionality is saying that we have 1300 ohms total, 48 volts. So 48 volts, 2, 5, and 6. Okay. We have all our numbers. So it's series, so you add it up. We have 1300. The law of proportionality is literally, I'm going to write it out like we're going to use it, but you just use whatever voltage you're looking for. E of R2 is equal to E total times R2 divided by R total. So if you take R2 and divide it by R total, that will give you the percentage of resistance that R2 is. So R2 divided by R total gives us what percentage? That's 500 divided by 1300. So 38.5% is what we're going to go with. Alright, so in series, the resistor that you are looking at gets the percentage of the voltage that it has of the resistance. So R2 is 38% of the resistance. It's going to have 38% of the voltage. What you do to find that is 48 times 0.385. .385, 18.48 volts. So now that I've done all that, let's say that you looked at what I did and went, yep, didn't get it. This is a series circuit, and all you have to do is work it just like a series circuit. So let's .037. It's so it's series, so you get the amperage. Everything has the same amperage. All right, so now that we've got all that, all we have to do is 500 times 0.037. Oh, there we go. 18.5. And that's basically the same number. Let's go back to our circuit. So all I did here was work it like a regular series circuit. 18.46. That's pretty close. Voltage drop across a load in a series circuit is, in series circuit, it's directly proportional to the resistance of the load, just like we saw. It's exactly the same percentage as the resistance of the load. Alright, using law of proportionality, calculate the... Okay, so this is literally the same question. Or no, it's a different voltage. It's only 15 volts. So it's slightly different, and also it's R1 instead of R2. Here is the work shown. So that's E total, which is 15, times R1 over, and this is R total. That gives you 2.38308 volts. That is that one. I literally just worked it. You can rewind it and see. And you can also work it as a regular ass series circuit. They gave you plenty of information to just work it regular. Find the supply voltage for the circuit shown in the figure below. Okay, so this is backwards, but still doable. I will show you how to do this one. Let's delete everything. Alright, and we don't know the voltage, but it's still the same resistances, so... Oh, I didn't have to erase that. Oh well. 3.7 volts is the number we're working with. So E1 is... .500 ohms. Alright, so we've got these numbers, and if you look at the chart, you can see that you've got two things on the same row. That's going to be 3.7 divided by 200. 0.0185. And since it's a series circuit, 0.0185, 0.0185, 0.0185. Now we're looking for E total. We know we have 1300 ohms. And now you just have to multiply it on out. So I'm just going to, I already have it in the calculator, so I'm just going to times 1300, 24.05. So roughly 24 volts. And there it is. Oh, I thought we were on. Okay, two more. Okay, using the law of proportionality, find the total current for the circuit shown in the figure below when the current through the branch is known. So there is, law of proportionality takes you right there. You have a book, you can just look it up. I will show you the work using law. I will not show you the work using law of proportionality because I didn't save it. Weird. Open in Paint. So you can also work this just as a regular ass parallel circuit. I total, I1, I2. We have I1 is 1.25 amps. E total, E1, E2. We can multiply across and get E1. It's a parallel circuit, so that will be all the voltages. 250 times 1.25. 312.5. All right, now we just have to, where's my pen? Okay. 312.5 divided by 300, which is our voltage of R2. 1.04. 1.04 amps. So that's going to give us 2.29 amps. Or thereabouts. It's a multiple choice question, so you don't have to get exact. 2.3. I'll call it 2.3. There you are. Oh, you didn't even need to do any math on this one? Let me show you. Look at your answer choices. 250 ohms gives you 1.25 amps. Okay? You know amperages are proportional. The other leg is 300 ohms. So you know it's going to be somewhere around, it's going to be lower than 1.25 amps. You know that for certain. Because higher amperage, or higher resistance, means lower amperage. So, it's going to be higher than 1.25, but it's not going to be beyond 2.5, because that's twice 1.25. So, it can't be above 2.5 and it can't be lower than 1.25. So, there's only one option that fits that answer. Alright, new question. Using the law of proportionality, find the current through R2 for the circuit shown in the figure below. R2. Okay. So you have 200 amps. And you know that this R2 is going to be less than half of them. But not a whole lot less. So that gets us down to between 65 and 80. Alright. What else can we find out? We could do product over sum, or y'all are doing reciprocal method. We could do reciprocal method to combine these two. Let me find this circuit, and I will show you. Paint. All right. Again, we're making our chart. Our total, R1, R2, 100, 150. I total is 200. E total, I1, I2. Did I leave an explanation on this one? I did. Okay, so this is your product over sum. Not product over sum. Proportional method. The law of proportionality. That's the word. This is the law of proportionality and how it's used. You can see they want the current through I2. So they use the percentage of current that is I1, the percentage of resistance, which is R1, of the total resistance times I total. And they gave them 80 amps. That's all well and good. But let's which one are we on? We're on this one. Okay. So we have open parentheses 100 to -1 plus 150 to -1. Close it, -1 one more time. So let's open parentheses 100 plus 150 one more time. So we have 60 ohms. Our voltage is 60 times 200, 12,000. E1, E2. So we're looking for R2, current through R2. We're just going to take 12,000 divided by 150, and that's going to give us 80. And that'll make this 120 amps. Done. All right, and that was the last one. So let me queue up the next one, next quiz, and we will get to going. I'll see you guys in the next one.